All right, so there's lots of ways I could make my sprite move. For this tutorial, I'm going to make the sprite move like it's going through a grid. Maybe this turtle will be part of a game where it's like navigating a maze or something in the end. So I want it to be locked into a grid. Um, First step, probably anything I do, is I'm going to actually, instead of just adding the drawing with a new sprite like this, I'm going to pull this out and save it using a constant so that I can do some more things with it later. So I'm just going to save it with a constant and then add drawing turtle. Once I do that, my code should work exactly the same as it did before. The nice thing now is I could change elements of it. So I made this turtle 24 by 24. So let's imagine I'm going to make a grid that is in units of 24 by 24. So first thing I want to do is just like think through the logic in general of the game. So I'll set up some constants for those things. Constant grid width equals 24. The game has a get size parameter, which will give it a width and a height. So that will give me the full game size. And then I can also do the grid size. The game size itself is going to be an object with a width and a height. So the grid size will be the game size width divided by the grid width, and the game size height divided by the grid height. So let me just dump this out to the log so you can see what I did there. All right, oops, there is no grid height. All right, so there we go. So, which is to say, if the game is 500 by 500, there are 20 by 20 grid units. Now, if I'm going to make this a grid, I might as well make it exactly the right size. So maybe I'll make it 504 pixels, which is a multiple of 24. So I'll go to 504 by 504. And now I have a grid that's 21 by 21. Very nice. All right, so now my turtle is going to move in positions that are 21 by 21. It currently has an X and a Y that are just arbitrary pixels. We're going to overrule all of that. So turtle update is a function that will run every time we draw the turtle. This is how I would sort of add properties to the turtle. I'm going to give the turtle a grid X. Maybe we started at 15, I don't know. And a grid Y, we'll start it at 15 too. And what I'm going to do in update is I'm going to set its X to be equal to its grid X times grid width. And the turtle Y will be equal to its grid Y times the grid width. All right, so that's now at the position I wanted it at. So why did I do that? Well, let's say that I want to move it over 1. I could just say turtle grid X plus equals 1. And there we go, moved over the 1. Plus equals 2. There we go, it moved over. So now the turtles, basically what I did is I made it so instead of using X and Y, we're going to use grid X and grid Y, and those will automatically update it. The next step is to add some keyboard controls. We call these handlers. They handle the different events that happen. Key press is probably the event you want to handle. And this is all documented in the docs that are linked at the bottom if you need to go understand it later. Key press will get a function. That function has an event, which is the thing we care about is it has the key, which is usually just a letter. So I often just like to do a log as the first thing to make sure something's working. So I'll pop open the console, I'll click over here and I'll type, and I can see, yep, it sees the different keys. The arrow keys don't work. My keyboard has a number pad, which is nice, but let's just use ASDF. That's kind of a classic for old-fashioned web games. And we can now write some if statements. So I can say if event key equals A, turtle grid x plus equals 1, event key equals D, turtle grid x minus equals 1, w turtle grid y plus equals is just shorthand for equals itself plus 1. And we'll make s make grid y minus equal 1. All right, and let's test it out. Oops. Pretty good. I can see that I actually got my keys backwards. I just wasn't thinking, so I have all my minuses and pluses reversed. And that's partly because it counts from 0, 0 up here, which might not be how I'm used to thinking. There we go. So now I have a turtle that hops around and moves in different directions. I could do some fancier things, like I could rotate him when he moves if I wanted to. So there's an angle keyword that makes it so angle. Now this is in it's in radians, so I've got to do it in terms of math.pi. So let's see if I got that right. Almost. I made him flip 100 pi over 2. Hey. Oh, wrong way. Negative pi over 2. There he goes. So now I could make each of these come with an angle. So d turtle angle equals math.pi over 2. It's w just be 0. And then if it's s, turtle angle equals math.pi, which is a 180. So now the turtle turns when we move him, which is kind of cool. All right, we could show you how to make this smoother, but I'm going to save that for another video. I'm trying to keep each of these under 10 minutes. So that is how you would move somebody in kind of a grid motion. And what's nice about this, just a quick note, the reason I use these variables is here it says 24, and actually I should probably make the target width here the grid width as well, rather than the number 24. The reason being, if I change my mind and I want this whole game smaller, I can just make the grid width into 16 there, and there. Now everything just works. I don't have to keep the number in there. If I want it bigger, I can make that grid width into 64. Oops. Where'd you go, turtle? Oh, you know what happened? 15 is bigger than, it's off the grid when the grid is this big. Here, I'll put it at 3, 3. There we go. Now I have it fitting on the 64 grid. So that's a nice trick, to use a variable throughout so that everything is sized to the turtle. And there we go.